Chapter 6, Geometry Review, Part 1. Let's decide whether each of our four figures that are shown on the screen are represented as polygons or not. Remember, a polygon is a plane figure that meets the following conditions. It is formed by three or more segments, called sides, such that no two sides with a common endpoint are collinear, and each side intersects exactly two other sides, one at each endpoint. So let's go ahead and take a look at our star shape here. And if we go ahead and extend this side of my star, alright, we can see that it will intersect with this side, and we see that it will intersect this side. So yes, our star shape figure is considered to be a polygon. Alright, next, look at the triangle. Is the triangle a polygon? It's made of three sides, which are segments. And if I go ahead and decide to extend this side here, we see that it intersects only two other sides, which is here and here. So yes, this figure is a polygon. Alright, circle. Right away we see we have no segments, we have no straight edges. Therefore, we don't need to go any further. It is not a polygon. And here, if you look at this odd shape, this would also not be considered a polygon because one side extends beyond the other two sides. So this is not a polygon. Alright, next you need to decide if polygons are convex or concave. Remember, if a polygon is concave, then when we extend all of the sides of the polygon, not one of them will go inside. If we extend a side and it does go inside the polygon, then it is considered to be concave. Alright, so let's go ahead and take a look at our star. Let's just say I want to extend this side of my star right here. And if I do that, we see that this portion of the line I extended is inside the polygon. So it is a polygon, but it's also considered to be concave. Alright, if we take a look at the square here, if I extend all my sides, you can see that none of these extensions go inside of my polygon. So this figure is considered to be convex. Okay, figure 3, same thing. What happens if I extend all my sides? I find that, and I'm not going to do every single one, but we can get the idea that this would also be convex. Alright, and my last polygon will go extend this side right here, and you see that we do have a portion of that extension that is inside the polygon, therefore it's considered to be concave. Alright, next we're going to talk about the Venn diagram that is on page 347 of your text. You were told last week that you need to memorize this Venn diagram and understand the characteristics that parallelograms, rhombuses, squares, and rectangles have. Alright, so let's go ahead and take a look at this. If you look here, you can see that a parallelogram is a rhombus, a square, a rectangle, and also there are two other types that we discussed, which were trapezoids and kites. But let's pay close attention to the areas that are overlapping in blue and red. We can see here that they show us three different types of rhombuses. And if we look real closely, we can see that a square can be a rhombus. And the same thing with a rectangle. A rectangle can also be a square. So, if a question was asked, such as, is a rhombus a square, sometimes, always, or never, we can look here and just look in the circle that says rhombus. There is a square there, so yes, a rhombus can be a square. But if you also know, the square is in the overlapping area of the rectangle. So a rhombus is a square only sometimes. A rhombus is a square when it's not a rectangle. Alright? So if they ask you, is a rhombus a parallelogram, we can see that yes, all rhombuses are parallelograms, so that would always be true. A trapezoid is also a parallelogram, and kites are also parallelograms. Alright, you want to go ahead and pay close attention to the definitions of trapezoids and kites. Alright, just like we talked about there being an isosceles triangle. An isosceles triangle is when we have a triangle with two congruent sides. We said that we could also have we also said that we could have an isosceles trapezoid where the legs were congruent. Alright, next you're going to have to find the value of x when given certain polygons. Find the value of x. Alright, let's go ahead and find the value of x with the given information. In our diagram, we're going to say that opposite angles are congruent. When opposite angles are congruent, then we also know that opposite sides are going to be congruent. So we can go ahead and take our expressions and set them equal to each other. So we would take 7x minus 5 is equal to 30. We're going to go ahead and solve for x, use a little bit of algebra. Let's go ahead and add out 5 to each side. These 5's cancel out. 7x is equal to 35. We still have not solved for x. So what we need to do now is divide out the 7. The 7's cancel out. And we have x is equal to 35 over 7, which is 5. Remember, they're telling you just to find the value of x and not the side length. Let's continue to find the value of x. The image below is one of a trapezoid. We're not making any assumptions about congruent angles or side lengths because no marks or indications have been given to us. But what we do know about is that all 4 interior angles of a quadrilateral, or in this case the trapezoid, is equal to 360 degrees. So you would take each one of your angle measurements here, add them together, 2x plus 3x plus 47 plus 78, and we would set that equal to 360. We would then combine like terms. 2x and 3x is 5x. 47 plus 78 is 125. Set that equal to 360. Using algebra again, we are going to solve for x. First, subtract out 125. They cancel on the left, leaving you with 5x is equal to 235. Still solving for x, we need to isolate the variable, so we are now going to divide out the 5, and we find that x is equal to 47. Now remember, we're just finding the value of x, not each degree. Alright, let's go ahead and find the value of x when we have a kite. Now remember, the definition of a kite says that only one opposite pairs of angles are congruent. The other two angles are not the same measurement. The rule still apply. It is still a parallelogram, therefore all four interior angles added together gives you 360. Since my x values here have to be the same because they are marked as being congruent, then we're going to go ahead and just take 85 plus 45, set that equal to 360. We know that 85 plus 45 is 130, and we can take that 130 and subtract it from 360. 360 minus 130 is 230. However, we have two x values that we need to find, and we know they are the same, so we'll just take that 230, divide that by 2, and we can find that each x value for our congruent opposite angles here would be 115 degrees. Therefore, x equals 115. Let's go ahead and continue with our last example for finding the value of x. If you look at our polygon, we can see that opposite sides are parallel. We can go ahead and make an assumption that since opposite sides are parallel and we have a polygon, then opposite sides lengths are congruent. So we can actually use any two pairs of opposite sides to solve for x. We can either use 2x plus 10 is equal to 12, or we can use 4x minus 2 is equal to 6. I'm going to go ahead and take the values that are highlighted in purple. I'm going to take 2x plus 10. I'm going to set it equal to 12. Subtract out the 10 from both sides. We get 2x is equal to 2. Divide out 2, and we find that x has a value of 1. Alright, so just to make sure that we do have the correct value of x, we'll go ahead and solve the other side. So I'm going to take 4x minus 2, set that equal to 6. I'm sorry, let's make that 4x plus 2. Alright, 4x plus 2 is equal to 6. Subtract out the 2. We find that we get 4x is equal to 4. Divide out the 4. X is equal to 1. So our value for x